Now, sound waves in a pipe. This is common enough science to know if you're designing any musical instruments. So, when modeling sound in these instruments, such as the tin whistle or anything similar, we have to note the difference between overtones and harmonics. So, as I said previously, we'll clarify what an overtone and what a harmonic is. So, we'll start with the fundamental frequency, which, as discussed in the last chapter, is the smallest frequency at which something can freely vibrate. That fundamental frequency is the zeroth overtone. And any multiple of the fundamental frequency, so for just some number k, is equal to the k minus 1th overtone. So if you had 4 multiples of the fundamental frequency, that's the third overtone. And yeah, the multiples of these fundamental frequencies, so this k times f0, that's known as a harmonic. So you always have one more harmonic to the number of overtones. Now, this actually changes depending on if your pipe is open or closed. So we'll start with a pipe that has a closure at one end. So in a pipe closed at one end, the fundamental frequency, or at its fundamental frequency, the length of the pipe is a quarter of the wavelength. So we can see here in this diagram. Now they've done it slightly differently where they put lambda, or the wavelength is 4 times the length, but it works the other way. I tend to just do length as a quarter of the wavelength. And then when you sort of go up, each harmonic increases by a factor of lambda over 2. So the second harmonic is lambda over 4 plus another lambda over 2, so that becomes 3 lambda over 4. Excuse me, third harmonic is 5 lambda over 4, and so on. Now, if the pipe is open at both ends, we can see that things work slightly differently. So the fundamental frequency, the wavelength is written like this. So the length of the pipe is just the wavelength divided by 2. And similar enough, every time the fundamental frequency is increased, the length also would increase by a factor of lambda over 2. So the second harmonic length is actually just the wavelength. Third harmonic is 3 lambda over 2, and so on. So we're going to be using one of these examples to model a musical instrument in the next video.